Hey everybody. Uh, Other concept from chapter 2, piecewise functions. Piecewise function is a group of functions that are put together to make another function. Okay, so piecewise function is made up of other functions that are pieced together. And you can think of it like sewing a quilt. You take different pieces of cloth and you sew them together. The pieces fit together. With our piecewise function, the different pieces of the functions that we put together cover the domain of that piecewise function. So let's actually draw one out and talk about it and conceptualize what we're looking at. Here we have a piecewise function. It's comprised of a linear function and a quadratic function. My linear is x plus 2, and that value, or the values for the piecewise function, will be comprised from x is less than 2 based off that linear function. And for x squared, a quadratic function, it will comprise the pieces of the function for x greater than or equal to 2. And to remember, open circle, parentheses, does not include the point. Closed circle, square bracket, includes the point. So let's just look at this. Linear function, x plus 2. So I know my y-intercept is 2. So I know I'm right there. And my slope is 1. So 1 over 1. So up 1 over 1, up 1 over 1. Down 1 to the left 1, down 1 to the left 1. So I have points now in which I can be able to graph. See if I can do that with my shaky hands. Okay, this is what my function should look like, something like that. Okay. Now I graphed more than what I should for a piecewise. What I'm doing, I'm just graphing both, and we're going to talk about it. Okay, so quadratic equation. For these, just simply plug in an x value to get your y value. So whenever x is equal to 0, y is 0. Whenever x equals 1, y equals 1. Whenever x equals 2, y equals 4. Whenever x equals 3, y equals 9. Whenever x equals 4, y equals 16. And I'll extend it out here. Whenever x is 5, y is 25. And whenever x is 6, y is 36. We'll take it all the way up there. There we go. So I have my points there. And how my graph goes is something like that. The main point that we have here of concern is on our x-axis, where x is 2. That's where my delineation is. So right here. This is where it matters. This is where it changes up. So I need to be able to look at graphing it from that point forward. Okay. So for my linear, I know that my linear equation is only less than 2. So my stuff that is greater than 2 for my linear equation or to the right, I'm going to get rid of. Okay. And I know that the points to the left for my quadratic, I'm not going to use. So to the left of 2 is not there. And then what I also know is that for my quadratic, it actually includes 2. So close circle on that one. And for my linear equation, it is going to be an open circle. And that is what I have for my graph. Try to highlight it some here. That is my piecewise function for what I was given. This piecewise function, the domain, go from negative to infinity to infinity. It'll include all x values because this just keeps going and going and going, keeps going on down, and this just keeps going and going, going. And my range will also be negative infinity to infinity because it just keeps going down from my range and it will keep going up from my range. Okay, let's look at one other problem. All right. For this one, if you want to, pause the video, look at it, see if you work it out and figure it out. I want you to give the domain and range and the equations for the piecewise function. Okay, so let's take a look here for our domain. Domain deals with what axis? Yes, x-axis. So domain, that's going to be what I look at. I look at my x-axis. So, going along here, does it cover all the points? Well, yes, this line extends all the way over here, so I know I'm going to negative infinity. All right? I know I'm going to negative infinity, and this line extends all the way, and it just keeps going, and I know that I will be going to positive infinity. Now, with it being a piecewise, I need to make sure that I at least have where these connect, where they're pieced together. I need to make sure I at least have a closed circle in one of those, and I do. So my domain will cover all values of x from negative infinity to positive infinity. Range deals with the y-axis. Okay. And if I look at this, okay, this is a lot different. I only have specific values of y that it touches. So for this one, what I have, and I'll start numerically and go up. So negative 5 is a value, negative 2 is a value, and 4 is a value. That's my only values of the range. It's just those numeric values where the y-axis is in play for each one of those. Now let's give the equation of the piecewise functions. This one here, this one's relatively easy, but it's always good to do our examples with easy ones. I have 3 equations that I'm going to deal with. Okay, so for 4, whenever the value of y is 4, we look at that. So what is the condition of x for that? And that is simply saying that whenever x is what? Greater than 2. See, whenever for y is 4, and if I look at my x value, and I have a less or greater than symbol, okay? And then my next one, let's see, we can do, how about negative 2? And the values for that, that's for whenever x is, okay, so here is my y value of negative 2, and I look at my x values, that's for x less than 2. And then my final one is for whenever x is a negative 5, or y is a negative 5, I'm sorry. Therefore, x will be equal to 2. So think about it. Whenever I looked at 4, look at how my line's going. It starts at 2, does not include 2, and it goes to infinity. So x just being greater than 2. And then whenever I look at for y being a negative 2, I look at my x value. That starts at 2, does not include 2, and goes to negative infinity. So x is less than 2. And then whenever I look at y being negative 5, I only have 1 point there, and that's at the coordinate 2, 5, so for x being equal to 2. Alright guys, watch your example videos from the publisher, structure your homework, reason through, think about what you're doing. Good luck with the rest of your homework.